In this module, I shall teach you about scalars and vectors. A scalar quantity has magnitude only. On the other hand, a vector quantity has magnitude as well as direction. Let me explain this to you with the help of a few examples. The picture on the screen shows a man pushing a box. It is important to tell if the push is in a particular direction, so that one knows in which direction the box will move eventually. Hence force is a vector quantity. Next image is that of time. So it is enough to tell a person that the time is, say 5 p.m., 12 noon etc. There is no need of telling about direction. So time is a scalar quantity. Next is about the distance between two people, which again does not need any direction. Hence distance again is a scalar quantity. About temperature, it is enough to quote the magnitude of temperature, say 30 degrees Celsius or 20 degrees Celsius, without having to talk about any direction. Hence temperature is a scalar quantity. In the next image, two quantities are mentioned about the runner, velocity and speed. Velocity has direction included in it and hence it is a vector quantity as compared to speed, which is a scalar quantity. Finally, the last image is of a weighing machine, which shows mass as 20 kilograms. This is clearly a scalar quantity. On the other hand, weight is a vector quantity because it is a force. Now let us determine the resultant of two vectors at right angles. In this example, it says that Rena leaves her house and drives at a velocity of 11 km per hour, north and then drives 11 km per hour east. Determine Rena's resulting velocity. So first we need to know the four directions really well, as shown in the diagram. Next is to construct a rough sketch using the given information, as shown in the figure. Since the two vectors are at right angles to each other, we can find the magnitude of their resultant vector by using the Pythagoras theorem. Hence the magnitude is equal to square root of 11 square plus 11 square, which is equal to 15.6 km per hour. The direction of the resultant vector can be found by using the SOHCAHTOA rule. Here the angle can be found by finding sine theta and then finally theta. The steps have been shown on the screen. Finally, we can say that the resultant velocity is 15.6 km per hour and is 44.83 degrees due east. So, well, that's all in this module.